Operations research. It is a domain which consists of a number of models for taking optimal decisions, either to reduce the cost or to increase the profit. And one such operations research model is assignment model, which is used for assigning certain things for certain facilities, so that after assigning and getting the job done, the total cost for doing all those things is going to be at its minimum, or the result out of doing all those things is going to yield the maximum profit. And in this particular problem, we have taken 5 jobs, and we are going to demonstrate and show how these 5 jobs are going to be allocated to 5 machines, so that it is going to yield the optimal result of getting a minimized total cost of completing all these jobs on these machines. In this problem, one thing which has to be noted is it has been solved using a workbook. Workbooks are very effective tools in order to teach, and at the same time in order to make the learner to learn by doing work. Please give a close look at how a workbook is being prepared and how it is being used. All the value adding things will be done by the learner, or all the non-value adding things many a times will already be available in the workbook as a print, or it will be written. That is how it goes. Let us go into the problem and let us see in this problem how 5 jobs are allocated to 5 machines in an optimal manner, and what are the steps which are being followed. The given assignment problem. There are 5 jobs and 5 machines. The 5 jobs are job 1 to job 5. 5 machines are M1 to M5. The associated costs of allocating a job to the machines is given in the table. That is, if you allocate job 1 to machine 1, it will cost 11 rupees. If you allocate job 1, the same job, to machine 2, it will cost 17 rupees. So automatically when you look at this particular table, you will say I will allocate job 1 to machine 1. Similarly, you will go ahead. But if you do like that, you won't get an optimal answer many a times. That is why you require the assignment model. It is required to assign one job to each of the machine. You can allocate only one job to one machine. If you allocate job 1 to machine 5, then no other job can be allocated to machine 5. That is what it means. Determine the optimal assignment of jobs so that the total cost to process all the jobs is minimized. So you have to find the job machine combination which is going to give the total cost of processing all these jobs through the machines is going to be at its minimum. So since it is a cost allocated related problem, it automatically cost has to be minimized. Therefore, it is a minimization problem. Suppose if profit had been given, it will become a maximization problem. So this is what has to be understood by looking at this particular problem. Whenever a problem is being solved, or for that matter, whenever doing anything, the structure in which we are going to do things really matters. What is first, what is second, etc. If it is going to be known very clearly, then the approach becomes very, very easy. So, in this assignment model problem, the first step will be check the rows and columns. The rows and columns should be equal. If it is not equal, what has to be done? That is the first step. Second step, we have to go and check whether the given problem is a minimization problem. If it is a minimization problem, we can go to step 3. If it's a maximization problem, you have to convert it into a minimization problem and then go to step 3. That is what is the structure. That is what is the steps to be followed. Third step will be row-wise reduction. Fourth step will be column-wise reduction. And after column-wise reduction, in that step itself, column-wise reduction and allocation. Allocation means you are going to allocate a particular job to a particular machine. So that will be the step. After, there is a procedure for allocating. You have to see row wise and column wise, and you have to cancel and things like that. But the fourth step will be column wise reduction and allocation. Once the fourth step is over, you have to check and see if the number of rows and the number of columns is going to be 5, then automatically there should be 5 allocations. That is, there are 5 jobs and 5 machines, therefore there should be 5 allocations. If there are less than 5 allocations, go up to step 5. What is step 5? Getting more zeros and allocating. There is a procedure for getting more zeros and allocating. After step 5, if you are going to check and see, in a 5 by 5 table problem, there should be 5 allocations. If it is 5, then problem is over. Otherwise, what you are supposed to do, you have to keep on repeating step 5 until the number of allocations is going to be 5 in this particular problem. And once the answer is, the problem is over, you have to write the optimal assignment in a tabular form. Therefore, there are 6 steps in this particular problem. And these 6 steps are really very, very clearly given. Now we will go to step 1. The problem is there and we will go to step 1. What is step 1? It is very clear. Number of rows. Check the number of rows and columns. Before going to step 2, the number of rows and the number of rows and the number of columns should be equal. The number of rows is 1, 2, 3, 4, 5. So I am marking it as 5. The number of columns 1, 2, 3, 4, 5. So automatically I am marking it as 5. So what happens? Number of rows equals number of columns. Therefore, number of rows equals number of, that is what it is. Hence, go to step 2. That's all. This is what is step 1. Now step 2. What is step 2? Check whether the given problem is a minimization problem. As I already told you, see, in the given problem, costs have been given and the objective of the problem is to reduce the total cost. The optimal total cost to process all the jobs has to be minimized. Therefore, automatically it is a cost related problem. Everything given here is a cost which has to be minimized. Then what happens? You just think and see. The data given in the problem is related to cost. Hence, it is a minimization problem. It is a minimization problem. And only if it is a minimization problem, we can go to step 3. Otherwise, we have to convert the given problem, which might be a maximization problem, to a minimization problem and then proceed. But here, since it is a minimization problem, we can directly go to step 3. Now we will go to step 3, row-wise reduction. Procedure for row-wise reduction. What is the procedure for row-wise reduction? Select the minimum element in a row. Subtract it from each and every element of that row. Do this for each and every row. That is what it is. Now, you see, the minimum element in the first row is 8. The minimum element in the second row is 6. The minimum element in the third row is 12. The minimum element in the fourth row is 17. And the minimum element in the fifth row is 10. So this is what I am going to write here. It is very simple. So 8, 6, 12, 17, 10. So whenever a problem is being solved, we have to tell or we have to showcase what is happening. It is not simply writing the values. That is very, very crucial to be noted. Now, you take minimum element in the first row. What happens? It is 8. Subtract it from each and every element of that particular row. So what happens? You see, this is the first row. You subtract 8 from each and every element. This will become 11 minus 8, 3, 17 minus 8, 9, etc. You will get. Then you take the second row. 6 is the minimum element because I have already shown you 6 is the minimum element. Now what you are supposed to do? Subtract the 6 from each and every element. When you do that, automatically what happens? You will get this particular table. That is, this will become 3, 9, 0, 8, 12, 3, 1, 6, 0, 9, 1, 4, 3, 0, 4, and 4, 7, 0, 11, 9, and 4, 0, 2, 1, 5. See, it is so simple. This is what is row wise reduction. Now, once this is over, we can go to step 4. Now, step 4 is column wise reduction and allocation. After column wise reduction, you have to allocate. Now, in this previous table, in the first column, which is the least, in the first column, the least is 1. In the second column, the least is 0. Third column, least is 0. Then, in the fourth column, the least is 0, and the fifth column, the least is, you can see, in the fifth column, the least element is 4. So you get all these elements. Now what you are supposed to do? In the same manner, the least element is subtracted from each and every element. That is 3 minus 1, 2, 3 minus 1, 2, 1 minus 1, 0, 4 minus 1, 3, 4 minus 1, 3. Like that you have to keep doing for each and every row with respect to the minimum element of that particular row. And this procedure has to be written here. What you are supposed to do? Select the minimum element in a column. Subtract it from each and every element of that column. That is what I explained. Now, let us do it. When we do it, what do we get? We will get these particular values. You will get 290, 88, then 21605 and 04300 and 370115 and 30211. See, after row wise reduction, this is the table you get. And once you get this particular table, we have to go in for the process of allocation. What is the meaning of allocation? You have to understand the steps. See row wise, and if you find a single 0, allocate it. Allocate it means you are going to put a box. And since you saw row wise and you made an allocation, you have to cancel the column. Now, the other way, see column wise. If you find a single 0, allocate. Since you saw column wise, you have to cancel that particular row. So if you see row wise and allocate, cancel the column. If you see column wise and allocate, cancel the row. This is what is the procedure. And there is another thing which is called as compulsory allocation. There are zeros, but there are no single zeros. Whether you see row wise or column wise, there are multiple zeros. Then it becomes compulsory. When you make a compulsory allocation, you have to cancel both the row and column. This does not happen in this problem, but just make a note of it. So see, it all depends upon what happens in your mind. I am seeing row wise, that I only know. I see row wise and I find a single zero, and therefore I allocate. I made an allocation. Since I saw row wise, I cancel the column. And again I see row wise. Now this is all cancelled. I see a single zero in this particular row. I allocate and I cancel that particular column. Now I see there are two zeros, I cannot allocate. Here I see no zeros are there. Here I see row wise. I only know. I see row wise, I allocate, and since I saw row wise, I cancel that particular column. Now again I see row wise. I see row wise. I see row wise. There are two zeros. I cannot allocate. I see row wise. No. Now going row wise is not going to help. Therefore, I am going to see column wise. When I see column wise, I find a single zero. I only know that I saw column wise, and since I allocated looking at column wise, I cancel the row. Now all zeros have been cancelled. No more allocation is possible. And at this particular point of time, I have to check and see in a 5 job, 5 machine problems, it is a 5 by 5 table. There should be 5 allocations. 1, 2, 3, 4. That is job 1 is allocated, 2 is allocated, 3 is allocated, 4 is not allocated to anything, 5 is allocated. Therefore, in a 5 by 5 table, there should be 5 allocations. Since it is not there, the problem is not yet over, and hence we have to go in for step 5. This is what it is. Since each row and each column does not have an allocation, we have to go to step 5. That is, we can say number of allocations is only 4 and it has to become 5, and until then we have to keep proceeding. This is what is step 4. Now what is step 5? Step 5, getting more zeros and then allocating. How to get more zeros? From the previous table, find the least uncovered element. And what you are supposed to do in that particular table, in the previous table, subtract it from uncovered elements. Retain covered elements as they are and add it to elements at intersections. So what is a uncovered element, what is a covered element, and what is a element at intersection, and what is the least uncovered element, we will see. See, in the previous table, see, if a line passes through the element, it is called as a covered element. If no line passes, it is called as an uncovered element. Now, if 2 lines passes, then you will get an element at intersection. So, this is a covered element, these are all uncovered elements, and these are elements at intersections because there are 2 lines passing. This is what it is. Now what has been asked in this problem? Find the least covered element. Now you can see least uncovered element, and if you see the least uncovered element, we will see it is 2. We will see whether there is something less than 2. Yes, there is 1. Definitely it will not be any value which is 0. It will be any other value other than 0. So you have a least element. If 2 ones are coming, you can take any one. So this is the least uncovered element. Please make an indication. Least uncovered element. So least uncovered element is 1. This 1 only I am writing it here. So least uncovered element is 1. Now what am I supposed to do? This 1, I am supposed to subtract it from all uncovered elements. So I will go to this table, all these uncovered elements, 2 minus 1, 2 minus 1, 3 minus 1, like that I will do. And if I am going to do that, what is going to happen? We will see. So all the uncovered elements, we have to subtract it. So automatically what happens? This becomes 1. This becomes 1. This becomes 7. This becomes 4. And here this becomes 2 and 2. And this becomes 4 and 0. So you can see from all the uncovered elements, from all these things I have subtracted 1. And I am going to retain covered elements as they are. These are all covered elements. These are elements at intersection. I will deal with it later. But these 6 and these 6, I will retain them as they are. I will simply transfer 9, 0, 8. Like that I will keep transferring. So what happens? 9, 0, 8. 1, 6, 0. Then 7, 0, 11. 0, 2, 1. And I will just bring it again. This also only one line passes. So this 0 and this 0 I will transfer as it is. 0, 0. Now only 3 elements have been left. And what happens? These are elements at intersections. And for elements at intersection, I will add this one. I will add this one. Automatically what happens? This becomes 5, 4, 1. That is what it becomes. So 5, 4, 1. So this is the new table which after, now what is this particular step? Getting more zeros and then allocating. Now this is what I am going to do. We have got more zeros. Allocating means actually in one of the steps we should write what is the meaning of allocating. I will just write it here. Allocating means, see, allocation means allocation rule. See row wise. See row wise. Allocate. If you find a single zero, that is understood. If single zero, cancel column. If you see row wise, see column wise, allocate. When will you allocate? If single zero is found. Since you are seeing column wise and allocating, cancel the allocated row. This is the rule. Somewhere you have to write it. It is better always. Now what you are supposed to do? We will start allocating. Now see row wise. I am seeing row wise. I find a single zero. You see, I find a single zero in the first row. Since I saw row wise, I will cancel the column. Now next, I will go, I will see row wise. I find a single zero. I allocate, I cancel that particular column. I get 2 zeros. Here there are no zeros. Here I get 2 zeros. Again if I go 2 zeros, 2 zeros. So there is no point in going row wise. I will go column wise. I find a single zero. When I see the first column, I find a single zero. I allocate. Since I saw column wise, I will cancel the row. Then again I will go to the second column. I will go to the second column. You can interchange and do it one time row wise, one time column wise. That is your wish. But we'll let us go systematically. Now we are going column wise. I will go to the second column. I find a single zero. And since I found a single zero by seeing column wise, I cancel that particular row. Now allocation is over. But I have to see whether the problem is over. In a 5 jobs, 5 machines problem, there should be 5 allocations. See, job 4 is not allocated to anything. Therefore, only 4 allocations are there. Therefore, problem is not yet over. So, automatically what happens? Step 5 is not over. We have to get into the procedure of getting more zeros and allocating. Among the uncovered elements, which is the least element? You see, again 1. There are 3 ones, any one you can take. I will call this as the least element, least uncovered element, least uncovered element. See, writing all these things will give any person a very clear idea that you know what you are doing. Just by filling up the values, that idea will not, you cannot convey that idea. So, see that the procedure is being written at least as a hint. So, least uncovered element, this one only I am writing here, where least uncovered element. What am I supposed to do? This one, I have to subtract it from uncovered elements, retain covered elements as they are, and add it to elements at intersections. So, this is what I will be doing next. So, what happens? I will subtract this 1 from all the uncovered elements. Therefore, this will become 0, 0, 0, 8. This will become 6, 3. This will become 1, 6 and 3. Like that it will happen. So, this is what I am going to do next. And we will see how it goes. Now, what happens? 0, 0, 0, 8. See, 0, 0, 0, 8. Then what happens? This becomes 6 and 3. 6 and 3. Then this becomes 1, 6, 3. See, 1, 6, 3. And there are no more uncovered elements. There are no more uncovered elements. Either it is a covered element or an element at intersection. I will retain all the covered elements as they are. You see, retain all the covered elements as they are. An element through which only one line passes. So, here it will be, see, 0, 8, 6, 0. These two elements are elements at intersection. Be a little bit alert. 0. That is why you should have a whitener always. And 5, 0. And you can see 2, 0 and 0. These two are elements at intersections. I will transfer it. 2, 0 and this will be 0. Now, elements at intersections. How many elements are there? 1, 2, 3, 4. This will become, you have to add it. 4 will become 5, 2 will become 1. This will become 3 and this will become 2. So, automatically 5, 2, 3, 2. 5, 2, 3, 2. And these are only covered elements. And covered elements you have to retain it as it is. We just forgot to do it, but we will just transfer it. 0, 11. 0, 11. That's all. Now, we will go into the procedure of allocating. How to allocate? See row wise. You need not write again and again how to allocate. One place, if you have written, it is okay. Somewhere in the first step or second step, whenever it happens, it's better to write it in the first step, even though I have written it in the second stage of finding more zeros. So, see row wise, single 0 is not there, single 0 is not there, single 0 is not there. Here I find a single 0, I allocate. Since I saw row wise, I will cancel the column. Next, I will go to the next, 2 zeros are there. Here, now if you see, after this allocation, you find a single 0. I saw row wise and therefore, since I made an allocation, I cancel the column. Now I go to the next, 2 zeros are there. Here, only 1 0 is there. This cancelled one is over. Only 1 0 is there. Allocated. Since I saw row wise, I will cancel the column. Next, I go to the next one. Next, I go to the next one. I find a single 0 in the 5th row. I see row wise and therefore, since I make an allocation, I cancel the column. Again, I go row wise. This is over. Again, I go row wise. Here, I find a single 0. These zeros are cancelled. line is passing through them. Therefore, I find a single zero, I allocate. Since I made an allocation by looking at it row wise, I cancel the column. See, now in this particular problem, 5 jobs, job 1 is allocated, job 2 is allocated, 3 is allocated, 4 is allocated and 5 allocated. So in the 5 by 5 matrix, there are 5 allocations. Hence, the solution is optimal. That is, the problem is over. So this is what is step 5. So step 5 is a step where you keep on repeating, getting more zeros and allocating, getting more zeros and allocating until the number of allocations is going to be equal to the number of rows or number of columns. That is because the number of rows and columns are equal, or each and every job is allocated to one of the machines. That is how you are supposed to check. And once the optimal allocation has been achieved, the answer has to be written in a proper manner. Which job has to be allocated to which machine and what is the cost. That is what we are going to write, the optimal allocation and the associated costs and the final optimal total cost in a table. That will be step 6. Now you see step 6, optimal assignment. What is the meaning of optimal assignment? Job 1, to which machine it has been allocated? It is very simple. Job 1 is allocated to machine 1. So you write it here. Job 1 is allocated to machine 1. Job 2 is allocated to machine 4. Job 3 is allocated to machine 5. Likewise, job 4 to machine 3 and job 5 to machine 2. What is the cost associated with allocating job 1 to machine 1? See, that you cannot get it from the previous table. That you have to go to the problem. See, job 1, machine 1. Job 1, machine 1, the associated cost is 11. This 11 only, I will put it there, 11. Next, job 2 to machine 4. Job 2 to machine 4, cost is 6. Job 3 to machine 5. Job 3 to machine 5 will be 16. Job 4 to machine 3 will be 17. And job 5 to machine 2 will be 10. So these will be the costs. And finally, minimum total cost for processing all the jobs through these particular machines will be the total of all these things. The total will be 60. So the total cost of processing all these jobs, job 1 to job 5, through the optimal allocation will be 60. This will be the answer for the problem. The answer is not only this, what is the optimal allocation and what is the total costs, and this will be the minimum total cost. Whatever kind of allocation you are going to do, the cost will never come below this particular 60, and that is the beauty of operation research models. It will give the optimal answer. It is operation research itself is a decision making tool, how to take optimal decisions. And here you see this, using this assignment model, we have arrived at the optimal decision. As a summary and end note for this particular topic of assignment model, very clearly we have seen what are the steps to be followed in solving an assignment model problem. And the structure is very, very important. What is being done first in the first step, then how to go to the second step, what are the things to be completed to go from second step to third step, and like that one by one, so that in the sixth step we will be able to write the answer. And this is what has to be learnt by a person who wants to use the model. The structure is always very important, and that is why I have used a workbook for solving the problem. And workbooks are so effective because it is easy for the teacher to teach, and it is going to make the student or the learner to work. And we all say that visual, auditory, kinesthetic, all kind of inputs has to be experienced by the student, and this is a kinesthetic. We are making the student, or we are making the learner to learn by doing. And I have demonstrated in this video how we can use a workbook to teach using a video, and in the same manner how we can make the same workbook to be used by a student in order to solve a problem. See, the best thing is important things the learner will do. All other things will be given as an instruction. That is the essence of using a workbook. Once a workbook is being prepared, then it becomes so easy for teaching. And use this video and experience the learning of operation research with the help of workbooks.